Hi and Assalamualaikum, and I hope everyone are in a good health. Okay, so today we will learn about second derivative. So what is second derivative is all about? Second derivative is actually a function that we differentiate two times. Okay, so let me see these questions. So we have gx is equals to 2 over 5 minus 3x to the power of 2. And then we bring the power to the numerator to get negative 2. Okay, and then we differentiate it using the power rules. So negative 2 times 2 to get negative 4, and then the power we need to minus 1 to get negative 3, and then we differentiate this function inside to get negative 3. And then we simplify these expressions, and then we differentiate it for the second time. Okay, so negative 3 times 12 to get negative 36, and then negative 3 minus 1 to get negative 4, and then we differentiate this function inside to get negative 3, and then we simplify it. Okay, and then this negative 4 we need to bring back to the denominator to get 4. So the answer is 108 over 5 minus 3x to the power of 4. Okay, next we will learn how to solve the problems by using the product rule. But in these questions, the questions already give us the first derivative of the function fx. So we just need to differentiate it one more time. Okay, so first, this function is a product of two functions, which is u and v. And then first we choose our u, which is 2x minus 3 to the power of 2, and then we differentiate u using the power rule. 2 times 2 to get 4, and then 2 minus 1 to get 1, and then we differentiate v. So v is equals to 8x minus 9, and we differentiate v to get x. Okay, so our second derivative is by follow this formula. So f double prime x is equal to u, which our u, times with dv dx, which is 8, plus v, 8x minus 9, multiply with du dx, which is 4x minus 3. And then we simplify these equations to get 12 minus x minus 3, to get 12x minus 3 for x minus 7. Okay, so these questions we need to solve this problem by using the quotient rule, since both ux and vx is differentiable to x. And then we choose our u and v. U is equals to negative 2x, and v is equals to the denominator 3x minus 1. And then we differentiate u and v to get negative 2. du dx is equals to negative 2, and dv dx is equals to 3. And then after we apply the quotient rule, which is v times with du dx minus u times with dv dx over v square. So after we simplify this, we will get the first derivative of this equations is equals to 2 over 3x minus 1 square. Okay, next, to find the second derivative, we bring the power of 3x minus 1 square to the numerator, and then the power will become negative 2. And then we can differentiate one more time by using the change rule. So negative 2 times with 2 to get negative 4, and then negative 2 minus 1, negative 3, and then lastly we need to differentiate this function inside to get 3. After that, we will solve this problem, and then we will get negative 12. And then this power of negative 3 will bring back to the denominator to get 3x minus 1 cubed. That's all. Okay, so for these questions, first, we need to expand this equation first. So, 2x times x squared, we will get 2x to the power of 3, and then 2x we times with 5x to get 10x squared. Okay, and then, using these equations, we differentiate it. We did the first derivative by using the power rules. 3 times 2 to get 6, and x to the power of 3 power 3 will minus 1, and then 2 times 10 to get 20. X to the power 2 will minus 1 to get x, and then we differentiate it for and then we differentiate it to get the second derivative, and then the answers will be 12x plus 20. Okay, so when the value of x is equals to 1, so what we need to do is we need to substitute the value of x with 1, and then we solve this problem to get 32. So the answers will be 32. Okay, so for these questions, first we need to simplify first. So one way to simplify this equation is by split it to 2 terms, and then we simplify this expression. We will get y equals to 2 plus 3x, and then we differentiate it. But before that, we need to bring the x to the numerator, and then the power will be negative 1, and then we differentiate it using the power rule. So negative 1 times 3 to get negative 3, and then negative 1 minus 1 to get negative 2, and then we differentiate it one more time to get the second derivative by multiply negative 2 the power of negative 2 with negative 3 to get 6, and then negative 2 minus 1 to get negative 3. So the second derivative will be 6x to the power of negative 3. And then we bring back x to the power negative 3 to the denominator to get x to the power of 3. And then when we substitute the value of x equals to 1 into these equations, we will get, when x equals to 1, second derivative of these equations will get 6. The value is 6. Okay, so for these questions ask us to find the value of k, given that hx is equals to 2kx to the power of 4 plus 3x squared plus 4x. So the first thing we need to do is to find the first derivative. So 4 times 2k, we get 8kx cubed plus 6x. 2 times 3, we get 6x plus 4. And then we find the second derivative of this function. So 3 times 8, we get 24k x squared plus 6. Then we need to substitute the value of x equals to 1 because h double prime 1 is equals to 30. So the value of x we need to substitute with 1. And then we solve this problem. Lastly, we will get k is equals to 1. Okay, hi. So for the last question, these questions ask us to find the value of k, given that a function, a gx, is equals to kx cubed minus 2x squared plus 7x. So we need to find the first derivative. Okay, so by using the power rule, 3 times k, we get 3k x squared minus 4x plus 7. And then, when x is equals to negative 1, then we substitute the value of x to negative 1. We will get 3k plus 11. Okay, and then, we need to find the second derivative of this function. So, 2 times 3k, we get 6k x minus 4. And then, when x is equals to 1, then we substitute the value of x to 1. We'll get 6k minus 4. And then, since g double prime 1 is equals to g prime negative 1, then we know that 6k minus 4 is equals to 3k plus 11. And then we solve this algebra, and then we will get k is equals to 5.